Hello, my name is Antti Roolila. This is climate lesson number 1, basics of the greenhouse effect. Let's have an overall look over contributions of greenhouse gases. This table is copied from Wikipedia. Even though Wikipedia is not a scientific source, in this case, this summary is a pretty good presentation about the situation today. We can see that water vapor is the strongest greenhouse gas, and the second strongest is carbon dioxide. This percentage, 26, is taken from the paper written by Keel and Trenpert. And you can really ask, is this the best what the science can say about the effect of a given greenhouse gas on the greenhouse effect? And then I can say that this is really the situation. Actually, it's even worse. And because this is the situation, on which basis the science can predict the future effect of carbon dioxide or other greenhouse gas effects, because that's the main question. This is the presentation of radiation emitted by sun and the earth. You will see this kind of curve, which is the radiation emitted by the earth in many presentations. And that's why I would like to introduce some basic facts. It is so that every surface emits radiation if it's facing atmosphere or space in the universe. And Max Planck's law says what is the relationship of spectral flux intensity and the surface temperature. This equation may look like very complicated, but don't be afraid. We will not use it later on. But it just says that if you know the surface temperature, T, then you can calculate these curves, because emission radiated by the surface is depending only on the surface temperature. And this letter lambda here is the wavelength of the radiation. In some presentations you can see frequency, and the wavelength and frequency are related in very simple way. Frequency is same as 1 divided by wavelength, but I prefer wavelength because it's much easier to understand. Here are the same two graphs of the sun and the earth, but now the scale is different. I have been using so-called logarithmic scale, and the reason is that in this way we can see more clearly the characteristics of the sun radiation. The earth radiation intensity starts from the 4 micrometer, and there is intensity up to 100 micrometer. And the sun radiation starts about 0.2 up to 4 micrometer. There is a trick in intensity of these two curves. The sun intensity values have been divided by 1 million because its intensity is so much higher than the Earth intensity. And the reason is the surface temperature of the sun, which is 5,500 Celsius degrees, and the Earth's surface temperature in average is 15 degrees. In this figure, we can see the visible light of the sun, and it starts from the blue, the wavelength about 0.35 micrometers, and it ends to red, which is about 0.7 micrometers. This is the wavelength band which can be seen by the human eye. Above 0.7 starts so-called infrared radiation, and we can feel it on our skin. There is a close connection between greenhouse effect and the Earth's energy balance. And that's why some slides about energy balance. As mentioned before, the Earth radiates energy all over the globe by every square meter. And the problem here is mathematically that the sun radiates from one direction only. And therefore we have to make a trick. If we could imagine that we have a circle here having the same circle than the Earth has, then it would receive this much radiation energy, 1,368 watts. But this is not equally distributed over the globe. It happens to be so that the area of this circle must be multiplied by 4 to make it to cover the whole globe. And that's why the incoming solar radiation must be divided by 4, and then we get this figure, 342 watts per square meter. And after this trick, the incoming solar radiation has been calculated on the equal basis if compared to the emitted radiation by the Earth. The greenhouse effect is a metaphor of the real greenhouse. In a real greenhouse, there are glass walls and a roof, and they prevent warm air to escape from the greenhouse. It means that convection is reduced. But the greenhouse effect of the Earth is a little bit different. We can think that we have insulation, a kind of insulation around the globe made by greenhouse gases, and they prevent heat radiation from the Earth's surface to escape into the space. Part of it will be escape, but it will be reduced. So what is the effect when this greenhouse effect is getting stronger? We can think so that this greenhouse insulation in a way is getting stronger. More heat is prevented to flow out. But that's not exactly the case. Still, the first law of conservation applies. What is coming in from the sun must flow out. It means that even though the greenhouse effect is getting stronger, the outgoing long-wave radiation will be the same. There is no difference according to the laws of the thermodynamics. And we know that there is one effect on the surface temperature. Here I have the temperature of the atmosphere, actually the troposphere, the lowest layer of the atmosphere. This graph starts from the surface and the temperature is about 15 degrees. And temperature decreases about 6.5 degrees per kilometer. And at the tropopause, at the end of troposphere, the temperature is about 55 minus degrees. When the greenhouse effect is getting stronger, the temperature profile will be slightly changed. And it can be seen here that the surface temperature is getting higher. The temperature at the tropopause should be the same according to the laws of thermodynamics.